In this video, we're going to take a look at expanded, condensed, and skeletal structural formulas. They're just different ways that organic chemists represent molecules. And you might ask yourself, why are there so many different ways to draw a molecule? Well, it has to do with the fact that organic chemists, sometimes we get a little bit lazy and we take some shortcuts. We just kind of assume that the person looking at our structures as we draw them can kind of fill in the blanks. So here we go. We're going to draw the expanded, the condensed, and the skeletal structural formulas. So I'm going to start out here with expanded, condensed, and skeletal. Skeletal structural formulas. All right, so for expanded, we're going to start out with a 2-carbon molecule. We're going to go carbon, carbon like this. And we remember that these carbon atoms like to have 4 single bonds. So like this, and like this. And then we would throw those hydrogens in there. So we would fill in the hydrogens. We'd make this saturated like this with hydrogen atoms. Okay. Now this is expanded. We're showing all of the bonds here. And if we're going to condense this, we would take those bonds away and we would write what you might think of as like the chemical formula. So for this one here, this would be C2H6. 2 carbons and 6 hydrogens. 2 carbons and 6 hydrogens like this. And the trick is, if I were to just give you this, like if I covered this up, if I just gave you this, could you draw this molecule out? You'd say, okay, well, there's 2 carbon atoms, all right, and then there's 6 hydrogens surrounding it somehow. Okay, so 2 carbon atoms with 6 hydrogens surrounding it. All right. Now, a skeletal structural formula for this, we'll get to that in just a minute. So I'm going to draw another one of these. This one's going to be a little bit trickier now. And I'm going to throw in, let's see, I'm going to go C2H4. C2H4. It's got 2 fewer hydrogen atoms. And the question is, can we draw this one out? So, all right, okay, there's 2 carbon atoms, so I'll draw these 2 carbon atoms joined together, carbon attached to a carbon, and then there's 4 hydrogens. All right, so I'll just kind of spread these out here. And we'll go with our 4 hydrogen atoms like this. Like that, okay? Now, are we done? Well, you might be going, wait a minute, carbon likes to form those 4 single bonds. And there's only 1, 2, 3. This one being shared. So this carbon has 1, 2, and 3. So we're missing a bond. And the way that we fix this is we would throw a double bond in like this. Okay? And then the question is, can you go from this to this? Like if I were to cover this up, could you say, all right, I've got 2 carbon atoms joined together, and I've got 4 hydrogens attached, and in order to make this work, I have to throw in a double bond. Okay? So this is a little bit lazy. It's easier to write this out. It's quicker, but it just assumes that we can recognize, oh, there's a double bond in there. We might not see that. And so this is where the skeletal structural formula comes in. This is kind of a combination of these two and makes it a little bit easier for us to see what's going on. So for the skeletal structural formula, I would have a carbon atom like this, and say a carbon atom with 3 hydrogens attached to it. So I go CH3, okay, CH3, there's a carbon with 3 hydrogens single bonded to a carbon with 3 hydrogens, CH3, okay? So this tells us, all right, carbon with 3 hydrogens single bonded to a carbon with 3 hydrogens. Now, if we take a look at this one, we would have CH2. CH2, and then there's the double bond. The double bond, okay, attached to a carbon with 2 hydrogens. H2. And so this skeletal structural formula shows us that there's a double bond there. And it's a little bit easier then to see, that there's a double bond here, whereas this one you just have to infer. Now again, organic chemists are a little bit lazy. Sometimes they'll draw it like this, sometimes they'll draw it like this, and they just assume that you can see that there's a double bond in